Okay, welcome everyone to another office hours on JSON. Today's topic is JSON schema. As usual, there's a couple slides and most of it will be demos. Feel free to ask any questions in the Q&A. And with me, I have Herman Beer, who is a product manager, and Haisheng Wang, who is a developer in my team, and we hopefully are able to answer all or most of your questions related to JSON schema. And with this, let's get started. So as you probably know by now, we have released a 23C database for developers. It's free, you can download it, and you can try out everything we show here on that 23C database. There's a lot of stuff targeted towards developers. We discussed the JSON relational duality views a month ago. There is a graph, there is domains. We're actually going to use some SQL domains here, and there is also JSON schema, and this will be the topic of today's session. And with this, let's get started. So JSON schema is nothing that we as Oracle invented, but it is a kind of standards draft that is being developed by a group of people working for various companies. So it's not like an official ISO standard. It's more like a loosely coupled group of people who have an interest in defining the JSON schema. And the main purpose is that it allows you to like annotate and validate JSON documents. So it is somewhat similar to XML schema. If you have been around long enough, you remember that before JSON, there was XML, and XML actually started out with something called DTDs, and then later they had XML schema. So in the XML world, you basically would start with almost always with a schema that defined your data, and the XML documents followed. With JSON, it's actually quite different, where usually people start with JSON and appreciate its schema flexible aspect, that they can just add new fields or change a singleton to a collection if their application requires so. And that basically makes JSON a lot more flexible than XML. XML schema was also quite complex. It had all these substitution groups, user-defined types, types inheritance, etc. So JSON is a lot simpler and easier than XML, and JSON schema is also simpler and easier to learn than XML schema. And JSON schema is not really that new to Oracle database. So in 19C, we have the JSON Dataguide. It was actually added before 19C. I think the first version was in 12.2. It was then heavily enhanced in version 18. And in version 19, you have a very mature feature called JSON Dataguide. And what it does, it scans or it samples your JSON data that you store in a column, and it derives a JSON schema from it. So we're going to look at that in an example in the second. And we use that to automatically create relational views, for example. So we could also use the data guide to notify someone if there is a new field, or to automatically add virtual columns. It's a very powerful feature. If you Google for JSON data guide, you will find in our documentation all the possibilities it offers. I also had like a series of 4 videos on YouTube where we looked into different aspects of what you can do with JSON Data Guide. But the short message here is, and we're going to see that in the demo in a second, if you run this JSON Data Guide, it gives you a schema from the data. So this was a 19C. Now let's look at what we add in 23C. And that is basically the ability to use a JSON schema for validation purposes and to do typecasting. We also use that to describe database objects. So you could have like a table or a type, and you can do a describe in a JSON schema format. And it also, JSON schema also serves as the basis for pre-check constraints. So you can add constraints to a table, like not null constraints, etc. And there will be like a new keyword, or there's a new keyword in 23C called pre-check, and that limits the constraints to those that are expressible as JSON schema. So pre-check basically means These constraints could be checked outside the database, like prior of an insert, using a JSON schema validator in your application tier, for example. So what we did with JSON schema, so we worked with the JSON schema group, and Oracle provided a vocabulary. So JSON schema, as we're going to see, has some limitation in terms of data types and in terms of really when we describe an object using a JSON schema. So here there's an example. For example, we say everything that's red is part of this enhancement where we want to say, actually, the object you look at, it's a table. And there's on data types some information really about the precision. So JSON schema usually works on these JSON data types, and you know that JSON has limited data types. It basically says like this is a number, but it doesn't say whether it's a float or an integer or a double. Whereas in the database you have different numeric types, for example. And this is information that we can now provide also in a JSON schema document. And we did not do like some Oracle proprietary enhancement. Instead, we worked with the JSON schema group and created like an industry-wide or a proposal for a vocabulary. So you see the link here. I can open that in a second also, just so we could take a look at it. But it's basically providing additional concepts for database use cases. And it's really open, like anyone can use this vocabulary, or we also invite people to enhance this. Yeah, and with this, let's get to the live demo. So this was all for the introduction. So very quickly, this is this vocabulary. Let me put this actually in the chat so people can also open this link on their own machines. And this just describes, so this is on GitHub. It's really an open proposal, and this describes why you would need some enhancements to JSON schema if you want to use it for database use case. But that is for you to read. I will start with the demo here. And what I'm going to do, as usual, is copy some statements from another window over here, and then I explain them. And if there's any questions, then please interrupt me, Herman and Haisheng. Just need to do this. Okay, let me scroll this to the right position. A second here. These JSON schemas are long. This is why I have to like scroll over like a lot of lines here. Herman saw it yesterday. Okay, so let's assume I have a table orders, and it has a column called data. It's of JSON data type, so I don't really know what's inside of it. I could say, well, let me look at those, but I got like 10,000 of these documents. So I could look at one, and maybe it has some fields, but there is no guarantee that what I see in one randomly picked document is really what I would see in other documents, because JSON is schema flexible. And what we have built here is this JSON Dataguide. So this is a kind of, I've showcased this in previous office hours, so this is why I don't go really that much into detail, but there is this SQL function, JSON Dataguide, which scans all the rows. In this case, it's the 10,000 rows. And it gives us back this document. It's hard to read here. This is why I have copied it out. It's basically giving us a schema for the instance data we've seen. So it's saying, well, data, what you look at is an object, and inside that object, you have these field names. There's like a field name user or a field name PO number, and it says what is the data type. So PO number is not surprising. It's a number data type. It also gives some information about the length, and you see here with this O colon, we have some optional arguments or annotations actually, and these allow us to provide or allow the user to provide some feedback if we create like a relational view. So we can take this schema and automatically create a relational view using JSON table over this data and then query it like a table. And this allows the user to like override the default column name that we would generate. But at the end, this is really just a schema. It goes over all these different field names that exist, cost center, etc. Every field I've seen is listed here. It also says that phone is an array, and inside we have other objects, I guess, like the type and the number. So it's like a pretty long document that describes how my data looks like. Now what I can do is, this is now, so what I've shown here, this would have worked on 19C, but the next step is already 23C. I can now add a constraint. So you remember that we had this is JSON check constraint. We typically used it on C lobs or B lobs to make sure that the data is actual JSON. And now there is like some new syntax, which basically said, I want to validate this data using a schema. So this is where we're going to put like the long schema. And you see here, these, what is this purple line under validate? So the parser here does not even understand this yet. This is very new. So let's copy the real schema inside there. So it's the schema that we've just looked at in the web browser. So it is quite long, as you can see. So this is now like a very long alter table statement. And we will see later how we can make this a bit shorter. So now I have added this constraint. And now let's see if how this affects the validation. And the first thing is we insert something into our orders document, and the field we're using here is not used. So there is nothing in our documents. It's about orders, but it's not about books. So the field name book title does not exist. So we would expect the insert statement to fail like intuitively, but it doesn't fail. It inserts that row. And let's roll this back just to make sure we don't pollute our data here. This is something we want to prevent inserting. So what does it mean? Does it mean our validation does not work at all? Let's try something else. Let's try to insert a array. And we see that is not valid. So there is some validation is happening. Remember our schema said that our type is an object. So at least the insertion of an array got prevented. Let's look at something else. Let's try to insert special instructions with a Boolean value true. I believe special instructions at the bottom, at the types, it's either a string or it's null, but not a Boolean true value. So hopefully this also gets rejected, and it is also getting rejected. But this begs the question, why did our first insert statement with a book title, I'm copying it back, why did this go through? And the reason is that by default, a JSON schema is open. It defines the field names, or if you specify some restrictions for a field name, like what we've seen here, like special instructions, then it defines it. Then special instruction can't just really be a string or a null, but the schema by default does not say that you could have additional fields. And this is what's happening here. This is an additional field, and JSON is meant to be schema flexible. So the validator says, okay, that's a field I've never seen. There are no rules for this field, so I just let it pass. So what we need to do is we need to close the schema. And for this, I'm just dropping the constraint, and I'm recreating it with like a minor modification. And it's basically just one line I'm changing at the bottom of the schema. I say additional properties false. So if you look here, it basically ends with special instructions. Here we have our special instructions, and I just added this additional properties false. And I run this. And now hopefully the book title is not being inserted because book title does not exist, and we do not allow additional properties. So what does this mean? Let's recap this for a second. So we basically had our orders table with 10,000 documents. We derived a schema using JSON Dataguide, and then we used this schema to add a check constraint that validates every newly inserted document. So what this could allow, for example, if you develop an application, initially you might be very, you might not know the final schema. So you might decide in the time of development, I need like, I don't know, like persons can have middle names, people can have multiple addresses, addresses in different countries have different formats. But once your application kind of is finished or gets closer to like the schema is known, you could basically use this mechanism to say, well, from now on, I really want to lock it down. So now whenever there is a change in my application data, I really don't want that to immediately go into the data. There is like some validation check happening, it gets rejected, and then maybe it was a mistake, or maybe we have to allow that in the schema, but this gives some control over the data that you are able to insert into a JSON type call. Good. So now, any questions so far? Does that make sense, Herman?
Yep.
You wanted to be the validator?
The only thing is you might want to quickly comment on what it means when you actually create that check constraint on existing data.
Mm-hmm.
When it goes through and when it doesn't go through.
Oh, yeah. Good point. Yes. So here, obviously, the schema was valid, or all the data was valid to that schema. If you have data that violates the schema, then adding the check constraint would fail by default.
Yeah.
And
there's one question about the error message.
Yes.
Which always seems to say array position out of bounds.
Oh, good. People are paying attention. Yes. Yeah, we could improve that. We could improve that. Actually, I filed a bug for that and assigned it to Haisheng yesterday. So
and there, yeah,
we definitely want to improve that.
Yes. Session, right?
Say again?
There might be more to come in that session, which makes things a little bit more holistic.
Yeah. No, the error message is not perfect at this point. Let me put it this way, but we're working.
And we're not GA yet.
Exactly. So, yeah, just interrupt me if there's more questions. I already mentioned that the schema is quite long. So if I create, so I had this this long check constraint, or I created the table, and then I have this long schema part of that. There is another way to make the create table statement or the constraint statement shorter. And this is by using a SQL domain. So obviously I need to provide the schema. So you see this is like a long statement. But what I do here is I create a SQL domain called orders JSON schema domain, I guess. This is what JS stood for. I created this yesterday, already forgot. And I basically say, well, this domain, it's named with this, and this is the validation rule. So maybe let me start with what is a domain. So a domain is basically, consider it like a lightweight type or user-defined type. It's basically a SQL data type. In this case, it's a JSON data type with some optional rules on that restricted or the constraint. And the constraint here really is this JSON validation constraint. Another example for a simpler domain would, for example, be, let's create a domain called shoe size, and it's a number, and the rule is that the values are between, what is it, like 6 and 15 or something like this. Or a domain called, I don't know, salary, which is like a positive number, something like this. So it allows you to put some, it's more like an annotation, which allows you to specify or to give some semantic meaning to a data type. And the semantic meaning is here, I have like a JSON, this is my data type. I have some validation rule, which is the schema. And I name this orders _ JS _ domain. So domains are also new in 23C, and this is what I'm using. So I create this domain. And now after I have this domain here, I can make use of it. So I create a table orders2, and this is the data type. And I say, well, this belongs to this domain that I just created. And that makes the create table statement a lot shorter. And now if I wanted to insert something into orders2, again, our example with like book title or title, basically it does not get inserted because it violates the check constraint of the domain. And I think this was the question here about this stacked error message. This error message is okay, the schema validation failed, but this one is at this point not so useless. I can also show that, I mean, if I just want to insert a document into orders 2, that is valid. So this is all some JSON that corresponds to the schema, then that insert should succeed. And there it is. Okay. Let's look again a little bit on this domain. I will create another domain, a shorter one, like the schema is a lot shorter. And this is information on an employee. So it allows us again to look a bit at the schema itself. So here I'm saying the schema I use to validate my employee domain, it's an object. And inside the object, I have different field names, like I have a name, which is a string. And I want to enforce that my employees' names are at least 2 characters long. It's quite arbitrary, but it just shows that you can have additional constraints on a field name. And then I say, well, my employees, they also get paid. And there is a minimum, a salary obviously is a number. The minimum is 800. I don't know what that means per month, per year, per hour, whatever. There is an email and there is a date when the employees joined. And now it's getting interesting. So pay attention that this says the type or the extended type is the date. So for all the other things here, you saw like salary is number, email type is string, but here we have like an extended type. And that is part of this database dictionary, where we have, obviously in a database, you have temporal data types, like the date standardized in SQL, which JSON unfortunately does not have, no type for timestamp and date. So this is why we kind of had to drill the JSON type system a bit open to say there is like extended data types. And then I can say, well, for a document, for a JSON document to be inserted, I require an employee to have a name, a salary, and a join date. The email is optional. So if this clause wasn't there, it would basically allow even empty objects to be inserted, because the default is that only if a field is present, it gets validated, but it doesn't have to be there. And this is what this required clause does. So overall, I think it is relatively easy to learn JSON schema. XML schema, I think, was more complex. So now this domain has been created, and again, keep in mind the join date. So just let's put some emphasis here that this is a date. Good. So now I create my table, employees, and it's very simple. There is an ID and there is the data, which is JSON uses this domain. And let's now insert some data. And what do you guess what happened if I try this insert? Well, it fails. It basically says there is a JSON validation error. There's no stacked error message underneath. I don't know why in this case, but it's basically saying, well, this is invalid. So how do we find out why it is invalid? So the JSON schema standards draft also prescribes a format on providing the reason why something is invalid. So not only like a yes, no, it actually is, let me just run this, then it's getting clearer. It also prescribes an output why something is invalid. So we know already it was invalid. So what I called here is a PL/SQL function. This is also new in 23C. DBMS JSON schema is valid. I give it like a document. I give it the schema. The result is whether it was valid or invalid, and the error is a JSON document, I believe, exactly, which gives the exact reason. So this is the inserted, the document I just tried to insert. This was the corresponding schema we used in the domain, and now we see it's not valid, and it gives us really now in JSON format the reason why it was invalid. And the reason, it's kind of quite long, because it basically says the entire document was not valid. It was something in the properties. In the properties, this was the join date. And then it says, well, the real error is like invalid type found. It was a string, but we expected a date. And I think this would be a nice reason, a nice message we could stack under the SQL error message, that people don't have to invoke the DBMS JSON is valid to find it. So there could be multiple reasons why a schema is invalid. Then you see here the errors, it's an array. Right now we only have basically this one problem here, but you could have in a larger JSON document, there could be more reasons why something is invalid. But basically now we know, okay, we gave it a string. Let me put the insert statement back that people can see it up here. So this was the problem. We said in the schema that join date is a date, but we gave it a string, and the validator basically said this is not correct. And now we have a problem at this point, because how do I express a date in my JSON if JSON does not have a date data type? And let's look into that. And I will present different options here, and I hope I explained them well enough that people get it. So otherwise, Herman, just stop me. And one thing to keep in mind is that our JSON data type is capable of holding additional data types inside. So if you create a JSON, so in this example, we are, I want to create some JSON from a relational source. I have a table called emp. Let's just do a describe here. So I have my emp table. It's from the Scott Tiger schema. Most people know that. And this has like a higher date column, which is of data type date. And what I'm doing here is I'm building a JSON data type. So this is a JSON type, a JSON object. It constructs a JSON data type, and there is like a field join date, and it gets its value from higher date. And the JSON data type that is being generated, that is actually able to hold the date. So this is why this insert will now succeed. I repeat it again, it will succeed because join date, although it's a JSON, internally it's a date. Like in our OSON format, this is our binary JSON, the date, or the fact that a value is a date is getting preserved. And this is why if you start from a relational source, this preserved. Does that make sense, Herman? Did I explain that?
Yes.
Okay, tried really hard. And I can actually prove that it's a date if I just query it. So we just inserted some data into it. Let's query this. So this is the entire data. So you see it's a JSON, and you see that if you look at this text version, it looks like a string. But if you extract it, or if you print out the type, you see that the type is actually a date. So what's happening is when you print this here, it's actually converting it transparently to a JSON string. So it is not stored in that way. It's stored in a binary format, but obviously we wouldn't be able to make sense of these bytes. So this is when you print it, there's like an implicit JSON serialize happening on top, and the JSON serialize will convert a date value into an ISO 8601 string. This is why, again, it looks like a string. It kind of is a string in the JSON text, but it's not a string on disk. Okay. The other way, so we're still back at the problem that how do I insert something into this table? We saw that, let me just repeat this again, that our initial insert failed. It was this one where I just said, hey, this is my JSON, comes from an application that only uses JSON text. So that's all it can give me. It's an ISO 8601 string. The other possibility you have is to annotate the string. So we have the ability in our JSON constructor. So here I explicitly constructed JSON, and I constructed in this extended mode, which basically means look for annotations like this $oracle date, and then convert this value to the date or to the type that is prescribed here. So there could be like double, for example, or I don't know, timestamp, but here it's an oracle date. So it basically means the join date is actually not this string, but it's actually a date. So this would work. And we see it gets inserted. Again, if we would query it, we would likely see it's a date here. Exactly. Where's our John Doe here? You see it's a lowercase. This is what we just inserted, and you also see the data type as a date. I mean, that is possible, but it's still some work, right? Like if you had some JSON from the application and you would have to add this $oracle date, that is quite some work. You also would have to know like which fields are a date, which ones are not. So this is quite cumbersome. And what we do instead is we rely on the JSON schema to do a cast. So what I do here is I create a domain. It's pretty much the same domain that we had, like we had our employee domain. Now I add like a underscore cast. And the only difference really is this keyword cast here, because now it means use this JSON schema not only to validate data, but also to cast data on insert. So now if our join date, which is like a date, and if the input is not a date data type, basically the validation would fail, we would first do a cast and then validate. So let's show the effect of this. So I created this domain. I create another table, employees 2. And that uses the data is stored also as JSON, uses this new domain with cast mode. And now the same statement that used to fail previously now succeeds, because this ISO 8601 date string is cast to a Oracle date, then inserted and then validated, and it basically succeeds. So now if I provide, if I replace the string, so this is still a string, but now instead of an ISO 8601, I put in like a non-date, like a cat, then the validation would still fail as expected, because cat, the string cat, cannot be converted to a date. So I think this is quite a nice feature. If you think about, you want to insert something into a JSON type column, you want to make use of these extended data types, for example, for proper range queries, or you want to preserve some aspect of the numbers, you want to make sure this number is a double, for example, then with this cast mode, it allows you to really convert the JSON text on ingestions to the data type you really prefer to have. Okay.
Great. We have a lot of questions for the
yeah. Good. Read them. Like, what is, you want me to read them, or yes?
Yeah. So basically, the question like, can we create a domain on another domain? So.
No, I think I don't think that is possible yet. It's also a limitation in our, if you look at JSON schema, right now all the JSON schemas have to be self-contained. Like in a JSON schema, you cannot, I mean, sorry, let me rephrase this. In JSON schema, you can import other JSON schemas. So you could say I have a schema for employee, and I have a schema for orders, and I let the orders schema point to my employee schema. We support that too, but only if it's in one big JSON schema. So if your orders document has like some internal reference to a customer schema, then it would work. We otherwise do not allow, let's say, cross schema references. And the reason why we are a bit hesitant is that we've seen that with the XML repository, that people registered XML schemas and then they moved data around. And now at import time, you had to not only import the data, but also import the schema, and the schema could have been present and it didn't really match. So it created like a lot of maintenance nightmares. And this is for now. In our first version, we really want to keep it rather simple and not introduce all these tricky cases initially. This is why no dependencies between JSON schemas, they're all self-contained, or they have to be self-contained.
Yeah, and I hope that's answered your question. The second question about the CAST, saying convert the numbers as a string, just like a salary, you have a 2,000. So the CAST can do that as well.
I mean, I don't have an example ready, but yes, we would do that conversion. So if you say, I want to store a value as data type X, and if you enable the cast mode, we would attempt a cast. And if it succeeds, the insertion goes through. If it fails, it's then a conversion error, basically. So we couldn't even validate because the conversion wasn't even possible. Yeah. I think the main purpose for this cast mode are really the enhanced data types. So things like strings and number that were given in the questions, both these types exist in JSON. So if your schema says, I'm expecting this to be a string, you can provide it as a string in your JSON data. The problem really arises with these additional data types that we have in a relational database, or even like in a MongoDB. MongoDB also has, in their JSON format, they have data types for timestamps, etc. So it's really like a deficit of the JSON data model that they did not think about these like a date or timestamp or different numeric types. So good.
Yeah, I think one thing that you should probably, it was not a question beta, but you should probably quickly comment on it, right? So we are doing, just to trying to put words in your mouth. So the extended types are there, to get specific Oracle type and type information on disk for better processing in the database.
Yes.
You mentioned things like, range queries, which are different on strings than, for example, on a date. But you haven't commented on the interoperability with other non-Oracle clients that would go after that data, that this is still preserved.
You mean if I go from Java? Is that?
No, just, we have a JSON data type, and JSON data type has limited types, right? So that means that's the lowest common denominator.
Yes, yeah.
And you added additional Oracle information here, right? Extended data types.
Yes, and it actually...
You have not commented on whether or not there are side effects for anyone that's working with that JSON.
Yeah, I'm not, well... I hope I understand where your question is going. Let me try to answer it. I would say if you are an application developer and, for example, you use Java and you work with dates in your application, then you would not express them as strings in Java, right? So there are data types to work with dates in programming languages, and the JSON or using JSON forces you to use these date formatted strings or other things, or these annotations with $date and $timestamp. And what we really try to do here is, if your application works with a date, you want to really store it as a date in your JSON on disk for exactly these semantics or range queries or whatever other methods you have on specific data types. It's also for numeric types like float, for example, or double. There is, for example, not a number or a minus infinity, plus infinity, etc. that exists for these data types that would not exist really in a regular JSON number. And that is what we really try to preserve here. So you can specify it in a JSON schema. It is stored, preserving these data types. And if you use JDBC latest version, which has support for JSON data type, and if you look inside from Java into these into the JSON, you will see it's actually a date or a timestamp or a float or a double. So it's really interoperable. I hope that answers. That was.
Yes, I think that was trying to ask you, right? And there's one more question, which I think I know the answer, but I asked the professional and the one that is on camera, whether we can use a domain object in the JSON schema validation procedure.
Isn't okay? Davis on it in defining.
I think that works at the moment, but.
Well, the schema, the domain is the database object. So you can associate a JSON schema with a domain, and the domain is a new database object. JSON schema is not a new database object. Like,
no. The question is the JSON schema validation procedure.
I don't think it accepts a domain at this point.
I think so too, right? That is something.
I found a bug for this yesterday.
That is something for GA.
Yeah, and this is actually a great comment. Like, if you find some functionality that you feel is missing or something nice to have, just let us know. And we are trying to get this. So this question here, like the lack of domain support in, or I wasn't able to use the PL SQL procedure with a domain. So I filed a bug for this. I think it's also on your plate, Haishank. So.
Yeah, that's exactly. Yeah, I put the note. I put the note.
Yeah, I'm not asking you for an update because I just filed it yesterday evening. That would not be fair. So.
And thanks to the question as well.
Yeah, exactly. So what we can do, there's also for the sake of time, let's move on a bit to leave some time for questions at the end. But we also added new dictionary views. So there is a view, JSON schema columns, which gives you the schemas that are associated with a table and a column, and it also tells you if we are in cast mode or not. So let's look what this contains for our example here. So we created these like employees and employees too. And you see that employees too used this cast mode, the others didn't. And I can also retrieve the JSON schema itself from this view. So this is where I would be able to get the schema out. Good. So now let's go to another use case of JSON schema.
Before we go on, right? Do you know offhand that the JSON check constraint does it support today the full constraint semantics, meaning with validate, no validate, deferred?
Yeah, it does. It should. Yes. Yes. Do you want to explain?
No, the question is the full semantic supported. I think validate, no validate with support. How about defer and other?
Yeah. That should all be supported.
Yeah. So probably for the audience out there who are not that familiar with what constraints are doing, that ties a little bit back to a question that we had asked Beta earlier when he created the JSON validation on the JSON schema on a table with existing rows. So when you talk about Oracle constraints have semantically different modes, right? One has to do with, what does a constraint do at the point in time when it gets created, where we have the two modes of validate and no validate. The validate mode means that at constraint creation time, all existing data will be checked whether it's valid or not. If you do no validate, you can probably guess it, right? We are implementing a constraint at a given point in time, and all existing data will be ignored and taken as is, and only data that is inserted or updated looking forward will be validated with the constraint. And last but not least, a deferred constraint means that we defer the constraint validation to the commit of an operation and not at an individual transactional level or individual statement level. It's a transaction level check.
Right. So deferred, for example, could mean that you make multiple updates to the JSON using JSON transform, for example.
Correct.
But an intermediate state might not be valid. But after you do all the patches you need to that JSON object and you then commit, then it gets validated. Yeah, that could be, there could be use cases where deferred makes sense. Yeah. And I think this no validate makes sense, for example, if you import data and let's say you've validated it on another database, you want to move it over, you want to do it quickly, then you could say just no validate or disable the constraint, load the data, and then enable it again. And, okay. So let's move to another use of JSON schema, and that is to describe an object. So this is my emp table. There's nothing JSON in here at all. This is the Scott diagram. You see very conventional data types. And I can invoke a function called describe. Actually, let's copy this over to JSON lint, make it easier. validate. So now we see the object emp, well, the title is emp. This is one of our enhancements DB objects. So this has the schema name. It's a.emp. A is the username. And from a JSON schema perspective, it's an object. But from a database object type perspective, it's really a table. So whether I describe a table or a type or a view, you will see that the database object type is different. And you see these are the properties, and the properties basically map to the columns. So there is a column emp no, and it will be basically if I generate, or we could do this, let's actually do an example here. Select JSON from emp. Let's see if this works. So you see, I'm just generating a JSON from all the fields. I don't specify like the field names. I don't override the default. And you see, this is what the default, it's all uppercase because the name is inherited from the SQL name. And this is then the JSON schema that would describe it. So it would say emp no, it's actually an integer. The ename, it's a string, but it could also be null. So we don't have like a not null constraint on the name. So this is why null would also be a valid value. Is there a case where we don't have? Yeah, for example, here with the emp no, this is a primary key. It cannot be null. So you see it has to be like an integer. Null is not a possibility. And down here, this is where we also see required is the emp no, because everything will have an emp no. And we also give some information about like primary key, which happens to be here also that field. So what this allows you to do, for example, is to, if you wanted to insert into this table, you could use the schema, for example, to validate all the values, or whatever you generate. If let's say you generate JSON from this table and you need some API description how this looks like, well, that is the schema that would describe this output here. I could also, for example, for those that like to work with PL SQL and object types, I'm creating like a little object here, and address type, street, city, state, and let me describe this. Now, I don't want to copy it over. I use this JSON serialized pretty printing, and basically I'm describing this address type. Now you see the object type here, database object type is a type. And again, it's the same idea. You have the SQL names are used as the field names, and you get the type information, etc. So it's easy to describe types, tables, views, etc. Also duality views. So this is something we demonstrated last time, that you can have a duality view. So I have a duality view on top of my emp table, and where I project out the employee number, the ename, and the salary. This is my view statement. And you know, duality views, I can specify like update rules. So here I'm saying I'm able to do updates, but no inserts, no deletes. And now if I describe this duality view, by the way, this is also like a brand new 23C capability that allows you to create updatable JSON views over relational data, that you basically get duality. Your data is both JSON, your data is also relational, so you can do the updates through JSON or through relational. You have both models can be used simultaneously. So we have this duality view. It only has one column. This is the data. This is our JSON view. If I would select from this view, you see that it's just like some JSON which has the field names, and then there is like some additional metadata like the e tag, which is used for optimistic locking, and like some timestamp, like a snapshot information if I want to do more queries at the same point of time. Like if you have not seen duality views, I recommend you watch the YouTube recording of the last month's office hours. They're really motivated why we need duality views, and I showed how to update them. But basically here what I could do is I could update, let's say, one record, change the salary, for example, and update it as a JSON, like basically make a change to the JSON and update the view, and that would update the underlying table. So that is what the duality view does. I'm not showing this here, but what I'm showing is the that there is a duality views dictionary view, and it basically says what's the view name, what's the root table, etc. And it also has a JSON schema that describes a duality view. So let's do that. Again, I'm using JSON serialize to do pretty printing. So now we say our emp_dual_v, it's actually a duality view. There are some properties. This view is updatable. Check means that it is enabled for optimistic locking. So the properties are checked. And then I see, well, my metadata, the E tag, the as of, like this is the SCN that I can use for point in time reads. And again, it's the same thing, like what are my field names? What are the data types? But then for every, we make this a bit bigger. So for example, for salary, we know, well, it's a number or null. This is the SQL precision. And then again, I have these annotations, which means I am able or I'm allowed to update the salary through this view. And the salary is also considered as part of this optimistic locking, the calculation of the hash value that you see in the metadata. So again, it allows you to programmatically understand a duality view and what you can do with that. So that I think simplifies a few things. Yeah, okay. Any questions? This concludes the demo. Are there any more questions?
The line is clean. No further questions. Seems you have done a good job, Peter.
Okay, then let's just thanks, Herman. We've done the live demo. I'm just putting up this slide again, kind of to emphasize again that you can download this database today and try out all these things that you've seen here. And with this, I end with a thank you and leave a few more minutes for questions if there are any. Okay, there is someone wants to speak, I guess. Should we unmute you or? Oh, the prior screen. Okay, yes. Yes, this one here. So probably, yeah, you can put your either this in the web browser or you could put your smartphone on here and then that should open a page which gives you information. Okay. Will any of this be backported to 19C is a question here. Potentially, maybe we do backport the DBMS JSON schema packages that might be possible for IS JSON, the IS JSON based validation. That's more elaborate, and I would tend to say no on that, but we do consider, so this is no guarantee that we will do it, or it's not committing to any timeline, and we may never do it, but it's something we do consider. But we first need to get the basic functionality done in, so that this is like this 23C free developer version. This was released like a month ago or so. There will be more 23C releases this year, such that we still do some enhancement and do some improvements projects, like the better error messages when validation failed. So we focus on this now. But if this is all stable and well done, then maybe we consider backporting some parts of it to 19C. So that is all I can say at this point. Sure, you're welcome. Okay, if there are no more questions, then I put this slide back on, like thank you, and hope to see you soon again. And we'll end the call now. Bye.